In this video we will be dividing polynomials, and we'll do that through a series of examples. Now this first one says to divide 2x squared plus x to the fifth plus 7 plus 4x cubed by x squared plus 1 minus x. Now it's not normal that you would see a polynomial written this way where it's not in order, it's not in descending order. And the reason I wrote it this way is just so we take extra care to make sure that any polynomials that we are dividing are written in descending order. So the highest degree here is x to the fifth. X to the fifth. Now there's no term that is x to the fourth, so what we do is we say plus 0 x to the fourth. We don't want to have any missing terms here. So x to the fifth plus 0 x to the fourth plus 4x cubed plus 2x squared, and then we are missing the x to the first term, so we'll say plus 0x plus 7, and then we'll divide that, and we're going to do this with long division. And same thing, I'm going to write the divisor here in descending order. Okay, so what we do is we say, we want to know how many times does x squared go into x to the fifth. And what we would do is that would need to be multiplied by x cubed. So x cubed is going to go in this position, and we know it goes in that position because it's going to go directly above the x cubed term. And then x cubed times the divisor here. So x cubed times x squared is x to the fifth minus x to the fourth plus x cubed. And then what we do is we subtract. So x, let's see, we should probably start at the right hand side. So 4x cubed minus x cubed will be 3x cubed. That's positive. 0x to the fourth minus negative x to the fourth. So that's like 0x to the fourth plus x to the fourth will be positive x to the fourth. And then x to the fifth minus x to the fifth is 0. So we don't need to write a 0 there. And I'm going to remove the plus sign here. All right, and then the next step is to bring down the next term. So we can write plus 2x squared here. And then we just repeat. So how many times does x squared go into x to the fourth? And that goes in x squared times, so plus x squared, and then multiply that x squared times each term in the divisor. We'll have x to the fourth minus x cubed plus x squared, and then we subtract. 2x squared minus x squared is 1x squared. 3x cubed minus negative x cubed, that'll be plus 4x cubed. And then x to the fourth minus x to the fourth, we'll have 0 there. All right, two more terms to bring down, plus 0x. This x squared should have a plus in front of it. All right, so how many times does x squared go into 4x cubed? So this goes in 4x times, so we're going to multiply the divisor by 4x. We'll get 4x cubed minus 4x squared plus 4x, and then subtract. And the reason I'm writing this in parentheses is just so I know that that negative sign is going to each term when we subtract. So 0x minus 4x is negative 4x. X squared minus negative 4x squared will be positive 5x squared, and then 4x cubed minus 4x cubed is 0. And then lastly, bring down the 7. So how many times does x squared go into 5x squared? And that's 5, so plus 5 here. We'll have 5x squared minus 5x plus 5, and then subtract. We'll have 7 minus 5 is 2, negative 4x minus negative 5x, so negative 4x plus 5x will be positive x here. Okay, so there's no more terms to bring down, and what remains down here, x plus 2, this is the remainder, and what we do with the remainder when we're dividing polynomials is we can write this as either remainder x plus 2. We could write it like that. Or what's more common is we'll make a second term, we'll say, or a new term, we'll say plus x plus 2, which is the remainder, and then we're going to write that over the divisor, x squared minus x plus 1. So all of this is the solution, and or the quotient. All right, so this is kind of an exhausting process. It's really easy to make mistakes. We have to make sure everything is lined up vertically correctly. We're going to try and avoid doing long division if at all possible. And we can do that if our divisor is of a certain form. And we'll see an example of that here coming up. All right, this next example says to divide 4x to the fourth minus 3x squared plus 5x minus 63 by x plus 3. Now, this x plus 3 is in the form x minus c. I guess the notes say x minus a, so let's say x minus a there. So if we are ever in this form, we can use what's called synthetic division. We could use long division, but my personal preference is to avoid long division whenever possible. So because I can divide this with a different method, I'm going to go ahead and use that. So what we do is we take the coefficients of each term and we write them in a row, so 4. Now we're missing the 0x squared, or cubed term. We're missing the x cubed term, so the coefficient on the x cubed is going to be 0. So minus 3 plus 5 negative 63, and I guess we don't need to write the plus there. So we're just taking each of these coefficients. That 0 is going to go here, 3 or negative 3, 5, negative 63. And then what we do is we draw a little box here, and what we do is we take the a value. Now the a value is going to be negative 3, so we write that negative 3 right here, and that's what we're going to, that corresponds to the divisor that we're using. Alright, so here's the process for synthetic division. Bring down the first value, that's 4. And then what we do is we take the 4, multiply by negative 3, which is negative 12, and then what we're doing is we're adding these two rows together. So 0 plus negative 12 is negative 12. Negative 12 times 3 is 36. Negative 3 plus 36 is 33. 33 times negative 33, negative 99. 5 plus negative 99 is negative 94. And then negative 94 times 3, I don't know that in my head, 27, 28. So 282 positive. And then we're adding there. So that looks like 282 minus 63, 9, 219. Okay. So what does this even mean? Well, what's happening is these are the new coefficients in the quotient. So what we'd say is, because originally we were dividing a polynomial that was raised to the 4th power, by doing this division we've reduced that by 1 degree. So what we'd say is the quotient is 4x cubed minus 12x squared plus 33x minus 99, and then this remainder right here, we can write it in a similar fashion as when we're doing long division. So we'd write plus 219 over x plus 3, and that would be the quotient here. I just glanced at my notes for the class, and it looks like I copied the problem down wrong. This leading coefficient in the notes is a 2. So if you wanted to solve this by dividing 2x to the 4th minus 3x squared plus 5x minus 63. Instead, that's fine. The process is exactly the same though. Okay, let's do one more example. So we see that the divisor is of the form x minus a, so we can use synthetic division, take the coefficients of each term, and there's no missing terms here. Actually, there is a missing term. We're missing 0x squared, so 0, 18. And then we're going to divide by negative 2 here. Okay, and then we're just going to proceed like before. We always bring down the first coefficient, 2, and then we multiply and add. So 2 times negative 2 is negative 4, add that to 1 is negative 3, negative 3 times negative 2 is 6, add that to negative 16, negative 10, negative 10 times negative 2 is 20, plus 0 is 20, then 20 times negative 2, negative 40, and we're left with negative 22. So that's our remainder. So the quotient, we started with fourth degree, so this division has reduced the degree by 1. So 2x cubed minus 3x squared minus 10x plus 20, and then minus 22 over x plus 2. And that's our solution. Now, these next few examples, we're going to be exploring a few theorems that have to do with polynomials. First one says, if a polynomial f of x is divided by x minus a, then the remainder, it's called r, is given by r equals f of a. What this means is, to quickly determine what the remainder is during the division of polynomials, a way that we can do that is, well, we can just input that value a into the function, and that'll tell us right away what the remainder is. So let's check this out with an example. This question says, to find the remainder when we divide p of x equals 2x to the fifth minus 4x cubed plus 5x squared minus 7x plus 2. And what happens when we divide that by x minus 1? What is the remainder going to be? Well, what the remainder theorem is saying is, well, let me try that again. What the remainder theorem is saying is, well, if we take this a value and we input it into the function, that will tell us what the remainder is. So p of the a value here, this is x minus, or x plus, x minus 1. So we're going to input 1 into the function. Let's see what happens. 2 times 1 to the fifth minus 4 times 1 cubed plus 5, 1 squared minus 7 times 1 plus 2. And then we just have to simplify this down. So 1 to the fifth is 1, times 2 is 2, 1 cubed is 1 times negative 4, plus 5 minus 7 plus 2. Looks like we're going to get negative 2 here. So p of 1 equals negative 2. What this means is the remainder, let's call it capital R, is negative 2. Alright, and we can verify this by doing the synthetic division. So I'm going to do that. So we're going to be dividing 1 into 2. We have a missing term, the x to the fourth term. So 0, negative 4, 5, negative 7, and 2. And let's divide here. So bring down the 2. 2 times 1 is 2, plus 0 is 2. 2 times 1 is 2, plus negative 4 is negative 2. Negative 2 times 1 is negative 2, plus 5 is 3. 3 times 1 is 3, plus negative 7 is negative 4. Negative 4 times 1 is negative 4, and we get negative 2. And that is our remainder. So that matches with what we found over here. So this is a quick way to find a remainder. We can just take the constant value, in this case it was 1, the constant value from the divisor, input that into the function, and that'll tell us what the remainder is. Then the second theorem in this section is called the factor theorem, and that says a polynomial f of x has x minus a as a factor if and only if f of a is equal to 0. So what this is saying is, if we take that value a and we input that into the function, if we do that and get 0, that means x minus a is a factor of the function. Now this makes sense because if we input a into the function and we get 0, this is telling us we have a remainder of 0 here. And when we're dividing, if something divides in evenly, we get a remainder of 0. So another way of saying that something divides in evenly is to call that a factor. So this should make good sense to us. This example says, given that 2 is a 0 of the function 3x cubed plus 2x squared minus 19x plus 6, solve the equation 3x cubed plus 2x squared minus 19x plus 6 equal to 0. Well, the key point here is that 2 is a 0. If 2 is a 0, what this means is x minus 2 is a factor, right? A 0 just means, well, when I input that value into the function, I get a value of 0 as its output. Well, if I get something that is 0 as the output, what we just saw in the factor theorem, that means that x minus that input is a factor. So what we're going to do is we're going to divide this using synthetic division. Now, let's back up just a sec. We have 4 terms here, and the degree is third degree. So normally what we would try to do is when we have 4 terms, we would try to divide this with synthetic division, or we would try to factor this by grouping. Well, if we try to factor this by grouping, we can factor out x squared. We're left with 3x plus 2. On the right-hand side, there's nothing to factor out, and these terms, or these factors, they're not the same. So I'm not going to be able to factor this one by grouping. So because we cannot factor this by grouping, we need to approach this with a different strategy. And the strategy is going to be to reduce this to a quadratic. And if we can reduce this to a quadratic, we know how to solve quadratic equations. So that's going to be the approach. Okay, so we're going to divide this with synthetic division using 2 as the divisor. So 3, 2, negative 19, 6. There's no missing terms here. Bring down the 3. 3 times 2 is 6. 2 times 6 is 8. 8 times 2 is 16. Plus negative 19 is negative 3. Negative 3 times 2, negative 6, and we get 0. This is good news. We want to get a 0 here because we know that 2 is a 0. So when we divide by 2, we should get a remainder of 0. If we don't get a remainder of 0 in something like this where it says that the divisor is a 0, that means we did the synthetic division wrong. And we just got to recheck our work. So what we've done is we've taken the function f of x, and we've factored this. We didn't factor it completely, but we found one of the factors. One of the factors is x minus 2, and the second factor is 3x squared plus 8x minus 3. These values in the quotient just become the coefficients here. And again, we started with a polynomial that was third degree, so after the division, we should have second degree in the quotient. Okay, so we factored this partially, and remember the goal was to reduce this to a quadratic. And what we have here in the second factor, that is a quadratic. Now, I probably shouldn't write this as in function form because we're trying to solve this equation. Okay, so what I could do is, well, I could take x minus 2. That's a factor. That's a binomial factor of degree 1. I could set that equal to 0. I could also set 3x squared plus 8x minus 3 equal to 0. And I could solve each of these. So that's going to be the approach here. So x minus 2 is equal to 0. So x is going to equal 2. And then what we need to do, I'll do this over here, we need to solve this equation. This is a quadratic equation. We've talked about how to solve quadratic equations. We can use the formula, we can try to factor. If you're a glutton for punishment, you can try to complete the square. My suggestion is let's factor this. And this polynomial does factor. So this is going to be 3x and x. This will be plus 3 minus 1. 3x squared. Yeah, that looks good. And then just set each of those factors equal to 0. So 3x minus 1 is equal to 0. X is going to equal 1/3. And then x plus 3 equals 0. So x is going to equal negative 3. So the solution to this equation is going to be any of these values. So x could equal 2, x could equal 1/3, or x could equal negative 3. All right, one last example here. This says to solve the equation 3x cubed minus x squared minus 20x minus 12, given that one solution is negative 2. Now, a couple things to mention. this says that one of the solutions is negative 2. That means x plus 2 is a factor of this expression here. So that's one thing to take away. And then negative 2 is a solution. Well, how many total solutions are there going to be? There's going to be 3 total solutions. And the reason we know that is because this is degree 3 here. So whatever the degree of the polynomial, that tells us how many solutions there are. And again, that also means how many zeros there are. Okay, so what we're going to do is negative 2 is a solution. So that means negative 2 is a 0. And what we're going to do is we're going to divide this, negative 20, with synthetic division. And because negative 2 is a solution, that means we should get a remainder of 0 here. So let's double check to make sure that that is happening. And we do get a 0, so that's good news. So what this means is, I'll bring the original question down. Okay, so I could factor this as x plus 2, and then 3x squared minus 7x minus 6. Okay, so we partially factor this, and then what we can do is that trinomial can factor again. That's going to factor to 3x and x, and let's see, negative 3, positive 2, like that. Okay, and then we just take each of these factors and set them equal to 0 to solve. 3x plus 2 equals 0, so x equals negative 2/3. X minus 3 equals 0, so x is equal to 3. So those are the 3 solutions. Okay, and so what we saw in this video was a few different strategies for solving equations that are not quadratic, higher degree equations. And we talked about how the zeros correspond to the factors. And so what we want to do is, well, this example that we just saw said, how do we solve this equation if we're given one of these factors? And it's really nice when one of those factors is given to us because we know what to divide by in the synthetic division. That gets it down to a quadratic, and then we know how to handle a quadratic. In the next section, what we're going to be seeing is, well, how do we solve an equation like this that is not quadratic, and we're not given one of the solutions? How do we approach that? Also, we're going to see, well, what do we do if these solutions are not real numbers? So what we've seen in this video are only solutions that are real numbers. What are we going to do when we have solutions that are not real numbers? So the next video we'll try to answer those questions.